Hello, everyone. When we are on the topic of networking, one of the things that we should not overlook is the type of networking. There are three different type of networking. One is LAN, MAN, and the third one is WAN. Let's take a look at them one by one. LAN stands for Local Area Network, and it is a private network that connects computers and devices within a limited area like a residence, an office, a building, or a campus. On a small scale, LANs are used to connect personal computers to printers. However, LAN can also extend a few kilometers when used by companies where many computers share a variety of resources like hardware. What are those different type of resource hardware? Printers, scanners, audiovisuals devices, etc. And software like application programs if they are shared, and of course the data. Moving on to the MAN. MAN stands for Metropolitan Area Network, and it is a larger network than LAN. It often covers multiple cities or towns. It is quite expensive and not a lot of organizations own it. Examples of companies using MAN is like a cable TV network, ISP, which stands for Internet Service Provider, or companies running their businesses across country. MAN provides higher speed from 1 gigabit per second to 100 gigabit per second. Now, a lot of companies these that uses MAN technology, please note that they actually have the cable, the physical cable connected from one location to another. All right, then moving on to WAN. WAN stands for Wide Area Network. A wide area network is a much larger network than LAN and MAN. It often covers multiple countries or continents. Satellite is used to manage the WANs. Now, internet is a big example of a WAN. And believe it or not, if you are communicating from New York to London, most likely that communication is having through the WAN when we run and when those cables are actually laid down on the Atlantic Ocean and they go from one country to another. Also, our DNS servers, which are domain name systems that resolves host name to IP address or a website name to an IP address, those DNS servers are also run on the WAN network. Hello again. In this video, we are going to cover protocols and the ports. Protocol, what exactly a protocol is? A network protocol are a set of rules governing exchange of information in an easy, reliable, and secure way. A protocol is just like language that two applications on either end of a conversation agree to speak in. If an application A, for example, is sending streams of bytes to application B, then application B needs to know how to translate those bytes. Most common protocols used in computer networks and the internet are TCP, which we know, Transmission Control Protocol, UDP, User Datagram Protocol, and IP, which is Internet Protocol. Now let's take a look at the ports. Ports, as the IP addresses identifies the computer, the network port identifies the application or the service running on the computer. The use of ports allow computers devices to run multiple services and applications. Now let's take an example to make it a lot easier. You can think of port as a phone extensions. With the computer's IP address being it's like a phone number, you can call the number or the IP address to talk to the computer, then dial the extension port to talk to a specific application. An application needs to be listening on a port in order to communicate. So you could have multiple ports on a single computer. So one computer could have one IP address or multiple IP addresses depending on what kind of functionality it has. But let's take an example of that computer having one IP address. What if you want to run not just one, multiple applications? Then of course you need different ports associated with that IP address. There are many ports that are in use in Linux system or in any computer system. But the most common ones that are mostly used are SSH, which is to connect from one system to another. And by the way, I'm listing these ports just to explain you how or what are those ports. So SSH stands for Secure Shell. It is used for connecting from one system to another. Then you have HTTP. HTTP is the service port for Apache and it runs on port 80. If you go to google.com, facebook.com, or any other website, you might see that it is connecting over port 80. But there are many other websites that you need to connect over secure connection, and that secure connection happens over HTTPS. It stands for secure, and for that, port is used 443. You could go to a financial firm websites or banks, all of them uses port 443 HTTPS. If you're transferring files from one system to another through FTP, that will be port 20. If you are trying to get the resolution from hostname to IP address and that request is going through a DNS, that request will go through port 53 and so on. There are so many different ports that are associated to services or applications in a computer. So hopefully this clarifies any confusions you have around protocols and ports. Hey boys and girls, in this video we are going to cover the different type of network devices. Network devices are called hardware devices that link computers, printer, faxes, and other electronic devices to the network. So that's the main purpose of all these devices. Such devices easily transfer data from one network to another. And these devices that I've listed up on the title are the hub, switches, modem, router, gateway, access point. Back in the days, each network device referred to a single device that performed a single function. That is no longer the case these days. Your modem, most likely, or the router from your ISP, Internet Service Provider, is a modem, router, switch, and access point all in one. You don't need to buy a single or separate device nowadays. All right, let's start with hub. What exactly is hub? Hub has several Ethernet ports, as you can see in the picture, that allow multiple computers to communicate with each other over a network. It is an obsolete device that you would never want to buy nowadays. It looks like a switch but works differently from the inside. Hubs are like switches but not as smart. Switches send incoming data to a specific port, whereas hubs broadcast all incoming data to all the active ports. So everyone who's connected to the hub, all the computers can actually see the incoming data. So Hubs shares the bandwidth across all the ports. So if you are getting the 1 gig of data, then the hub has to share that across all the ports. Whereas in Switch has dedicated bandwidth associated to each port. Now, hubs are considered on the first layer of the OSI, which is the physical layer, physical devices. All right, moving on to switches. Switch have a smarter job than hubs in general. A switch improves the capacity of the network. A switch also has several ports that allow multiple computers to communicate with each other over a network just like a hub. Switches read incoming packets, hardware addresses, which is what are the hardware addresses? The MAC addresses, to transfer them to their respective destination. That is why incoming data is sent to a specific port. Now, compared to hubs broadcast all incoming data to all active ports because hubs are not smart. They do not know the MAC address of each of the computer connected to each port, so they cannot send that data to each computer. They just simply send it to all the ports and everybody sees it, which is not a secure way of communicating data from one computer to another. Switches are considered the OSI layer 2, which is the data link. Switch provides dedicated speed on each port, unlike hub that we discussed already. Each port has 1 gig. If it is getting a 1 gig of speed, it will have its dedicated speed on that specific port. All right, moving on to the modem. I'm sure you have heard of modem many times. Everyone, if your internet service, if you have it in your home, you probably have a modem. A modem is a small box that connects your household to the internet using cables. It acts as a digital translator, taking an information signal, internet data, from your cable or phone lines and making it accessible to your computer. Mostly modems has one port for coax cable. And you probably look at the back of the modem, you're going to see a cable that has a little pin sticking out and has a screw built in on top. So you have to tighten the screw on the coax cable port. And the second port for on the modem is the Ethernet jack, which can either go directly to your computer or a switch or a hub for extension. All right, moving on to the router. Router is the smartest of all. Router works at layer 3, which is the network layer of the OSI model, which deals with IP addresses. A router is a device that joins network together and routes traffic between them. At home, this typically means the router connects your local network to your ISP network. So if you have a switch, if you have two switches, for example, you got to put a router in the middle to connect them together or route the traffic. Nowadays, a router serves as a hub, a switch, a modem, a gateway, and router functionality itself all in one. And you get that from your ISP, Internet Service Provider. A gateway and a router. So now there's a difference. So you probably heard of gateway as well, which we discussed. A gateway and a router are essentially the same. The term default gateway is used to mean the router on your LAN, which has the responsibility of being the first point of contact for the traffic to computers outside the LAN. So primarily, there is no difference between a gateway. Gateway, we define the IP address of the gateway, and that IP address sits on that physical router. All right, so let's take an example and let's draw it out. So here we have our computer with the network port on it. What we do is we connect that port to a switch, and then switch connects to a router. So back in the days when there was no switch, you will connect it to the hub. But now that's how you deal with nowadays. It's a switch, and switch connects to a router. Then that router connects to a modem, and that modem connects to your ISP with through a coax cable. And then you get the internet. Now, the elimination happens where these devices come together. So instead of having a switch, your router has become or taken over the responsibility of the switch, and you could connect directly to your router, which serves as a switch too. If you look closely, this router, see you have multiple ports. The reason you have these multiple ports is because it's acting as a switch as well, which is allowing multiple computers to connect together to one switch. Similarly, you don't need a modem anymore. You could just get rid of the entire modem, and your router, which has a built-in functionality of the modem, can connect directly to your ISP. All right, now let's get to the last one, which is the access point. Access point are used for extending the wireless coverage of an extending existing network and for increasing the number of users that can connect to it. A high-speed Ethernet cable runs from a router to an access point, which transforms the wired signal into a wireless one. So, in a simple way to put it, an access point is just an extension of your Wi-Fi network. If you have a huge house, let's say you have 4 floors and you're not getting a network signal from your router on the Wi-Fi from first floor to the fourth floor, then what you would most likely do, you would put an access point on the third floor and run a wired cable from your router to that access point, and that access point will serve as a Wi-Fi router extender to all the devices that are connected to your home network. Hello everyone. In this video we are going to cover how internet works. Internet is a vast network that connects computers all over the world. Through the internet, people can share information and communicate from anywhere. So to better understand how internet works, let's visualize it. We have our computer, and when we power it up, we want it to go to the internet. So we will double click on our browser. So our browsers are like Internet Explorer, Firefox or Google Chrome. And then let's say we wanted to go to the page google.com. How your computer knows how to get a Google page or Hotmail or Facebook page or any other page for that matter. It sends that request to a router. Your router is the router or a modem that is provided to you by your internet service provider. That internet service provider, of course, charges you a certain amount per um, as per the bandwidth or on a monthly basis. Then that ISP, when it gets that request, it sends that request over to another server that is called a DNS, and DNS gets that information to the internet, and that's how you get the page of Google. Now, in this entire process, you're probably wondering, what is a DNS? Well, DNS plays a very critical role in this entire process. DNS stands for Domain Name System. It's basically a database that keeps the records of IP addresses to hostname to, IP to hostname, and hostname to hostname. So, why do we need to keep track of that data? It's because when we go to the URL www.google.com, our computers don't understand letters. They only understand the digits or the IP address that associated on that computer. So when you go to your router says, "Hey, who is google.com?" Then router sends it to ISP. It says, "Who is google.com? I don't understand because it has to be an IP." So then it consults to that DNS server. And DNS server says, "Okay, you know what? Hold on a second. Let me find out who is google.com." And then it checks its record and says, "Ah, I found it. Google.com is this IP 205, 203, or whatever that IP address." And that IP address is actually served back to your computer, and your browser translates that IP back to google.com. So who manages how many servers? What are those DNS servers? There are altogether 13 root DNS servers in the world today, and they all labeled starting with A to M. These DNS servers are the one who keep track of all these records. If you go and buy a website, for example, imranafzal.com, you need to register that website. Now, if someone needs to access that website, then I have to have that record of that website to be created in one of those 13 DNS servers with the IP address, that static IP. So this way, every time someone tries to reach me, they can get that translated to a right IP, and that right IP gets associated to a server where that host or where that website is hosting. So what are those 13 servers? Those 13 servers starts with A through M. On the second column, you're going to see it has its IPv4 addresses and also IPv6 addresses as well. On the last column, you're going to see the operator of the company that owns or manages those DNS servers that are responsible to continue to update across all those 13 DNS servers. All right, so let's log into our Windows and Linux machine, and let's take a look how DNS works when we try to reach Google. So I am going to start up my Windows search bar, and I will type CMD to open up command prompt. Okay, so when I try to ping www.google.com, ping is, by the way, a command that you will use to make sure the server that you're trying to reach is reachable. So ping www.google.com. So when you do this and hit enter, you're going to see that it is bringing back the IP address of the Google, the 172.217.12.164. So let's say if you copy this, edit and copy, and now you go to your Firefox and paste that IP address here and hit enter, you're going to see it takes you to Google. See, that's how that DNS comes in because DNS is the one that actually translating google.com to that IP address or that IP address to google.com. When you go back to it, in order to find out who is your DNS server, you could do NSLOOKUP and type again google.com. NSLOOKUP is the command that tells you name server lookup, like what is the name. So it will tell you that I am going to go to my DNS server. In this case, this is my DNS server, which is my router that is in my home. The address of that router is 10.253.1.1. That router is also serving me as a DNS server. So it went to that router, and the router said, sorry, I don't have the answer to find out who google.com is. So I'm going to send you to another server, which is non-authoritative answer that it went out on the internet to the DNS server, to the ISP, and it found the IP address, which is google.com, and the IP address 172.217.12.164. So now that's how the DNS functions. Similarly, if we go to our Linux machine, and in the Linux machine, if we do the same thing, ping www.google.com, that ping command works in Linux as well. You will see it is bringing back the IP 172.217.10.100, which is of course different from this IP. It's because Google has not just one server, but many servers that are actually serving their websites. So if you wanted to do this 172.217.10.100, 172.217.10.100, you will see it will bring us back to the Google page as well. Same thing, let's go back, and if I do NSLOOKUP, that's the same command that works in Windows as well as in Linux. NSLOOKUP.www.google.com, and you will see it went to my router, which is 10.253.1.1, and the router says I don't have that answer. I'm going to go to the DNS server outside through my ISP, and I will get you that information. And it comes back and says, hey, I found the record. And the record is www.google.com, and it is translating that record to this IP address. And that information is coming from one of those 13 DNS servers that I have talked to you about. That's how the DNS works, and that's how the complete internet works.